For problem 1 of the applied algebra problems, we have a design problem where we're trying to calculate the number of holes in a circular pattern with a given angular distance. Here our angular distance is 15 degrees, and we want to find out how many holes are going to go into the circular pattern to have a spacing of 15 degrees. So to do that, we have to manipulate the equation to solve for n, which is the number of holes, and then plug in our numbers. And we can see that the part that we're designing, it looks like a flywheel for a motor. And here's our angular distance right here. It's the angle between each hole in the circular pattern if the holes were to be equally spaced. So let's get started with trying to get n by itself. So we start out with d equals 360 degrees divided by n, and we want to get n by itself. So I'm seeing the most reasonable thing to do would be to move n to the left side by multiplication, and then to move d to the right side by division. So let's get started with that. So first, we have to multiply both sides by n. That's going to give us dn equals 360 degrees, because the n's cancel out. If you divide by n and then multiply by n, it's going to cancel out. So we have dn equals 360 degrees. Then to get n by itself, we divide by d. So these d's are going to cancel out, and then divide by d on the right side. Keep doing the same thing to both sides of the equation so the equation stays true. And here we end up with n equals 360 degrees divided by d. We plug in our numbers here. N equals 360 degrees divided by a 15 degree spacing. And that's going to give us 24 holes. There's our answer. 24 holes.